Alright, this is part 2 of our lesson about arc length, sector area, and volume. In this part we will continue to deal with area and sector area and circumference. We won't get into volume just yet. Alright, so basically we're going to stick to 2 dimensions for now. Okay, number 9. Okay, so this one is interesting because we are supposed to find the circumference. Okay, but what we are given, this 15, what does this represent? Alright, I'm asking good questions today. This 15 represents this arc length right here, arc length AB. So, as soon as I see that we're dealing with a sector, an arc length, alright, it's like a slice of pizza, I know that we're probably going to be dealing with part over whole equals part over whole. So let's go ahead and talk about that. Alright, part over whole equals part over whole. Now on the right hand side, degrees, right? So part over whole, 60 over 360. Now on the left hand side, be careful. This 15 is the part. Alright, it's just from A to B. It's not the whole circle. So if we're going to do part over whole, then the 15 should go in the top because it's the part. The whole is what we're looking for. We're supposed to find the circumference. The circumference is the length of the whole circle. So I'm just going to put a big old C there instead of X to really remind me that I'm finding the circumference right now. So all I have to do is find C and I'm done. So it's actually pretty simple. Now 60 over 360 is going to be 1/6, don't you know? 60 over 360 reduces down to 1/6. Of course, so I have 15 over the circumference is equal to 1/6. If I cross multiply, if I do this diagonal, C times 1 is just C. So I already have circumference by itself. So 15 times 6, that's 90. Now circumference is length, so that'll be 90 inches. Okay, that's it for number 9. Alright, number 10 looks interesting. We're supposed to find the perimeter of the shape. Now, please remember that perimeter is the outside part. So when we find the perimeter of this shape, we are looking for this. Okay, we're looking for this right here, all the way around. Okay, so that green length is what we're looking for. Now, we can split that up into pieces though, to make it easier to see what's going on. Well, third, okay, so it will help if I visualize the rectangle that I would form if I drew in these diameters. Okay, like this is diameter. It's supposed to be a diameter. Okay, so what am I going to do? So I'm looking for every piece of this green. And every time I find a piece, I think I'll color it in orange. Alright, to sort of check it off. Well, I have 2 of the pieces right now, don't I? Okay, because I know this piece already. It's 15. And that's going to match this piece up here. Okay, because that is also 15. Okay, so far I've got 15 and 15. So really I just need these 2 green parts on the sides. Now, the most efficient thing to do is to recognize if you took the green part on the left, okay, which is like this, and then if you took this green part on the right, which is like this, Alright, you put them together, what do you have? You have one whole circle. So if I found the circumference of this circle, that would be the remaining green part that I needed. So that's the most efficient thing to do. Okay. Now, what is the circumference of the circle here? Well, the diameter here is 9. See it? So the radius is going to be half of that. So that's 4.5. Okay? Situations like this are why they have another form of the circumference formula. So sometimes instead of 2 pi r, they just say pi d, pi times diameter. So that would make the circumference of this green circle would just be, the diameter was 9, so that would just make it 9 pi right away. Okay, so 9 pi. However, if you just cannot handle one more slightly different formula, then you will have to go through these extra steps of taking the 9, dividing it by 2 to get 4.5, and then you turn around and go, okay, so 2 pi times 4.5, but then the first thing you do is you do 2 times 4.5, and you get right back to 9 again, 9 pi. So it was silly to cut it in half and then double it when you could have just left it 9 in the first place. But hey, do you. Okay, so now we've got the circumference, which is both halves, okay, on the left and the right. So that's a total of 9 pi. So, you know, I could split it up, I guess, and I could call it, if I do half of 9, you know how that's 4.5? So I could say I have 4.5 pi over here, and I have 4.5 pi over there. But there's no point in that. So the goal is to add it all up. So I have the 15 and the 15. So it's like I have the 15 plus the 15, and then the 2 halves of this circumference here. So if I do the 4.5 pi plus 4.5, of course that came from 9 pi in the first place. So, alright, so it's the 2 oranges plus the 2 greens, which was the 9 pi. So as far as an exact answer, it's going to be 30, alright, 15 plus 15 is 30, plus 9 pi. Alright, that's my exact answer. You can't put it together and make 39, because this one doesn't have a pi. And the units will be, it doesn't look like they gave us any units, so we're just going to have to leave it alone. So that's the exact answer for the perimeter of the entire shape. Okay, or we could turn it into a decimal, 30 plus 9 pi. That's 58.27. Okay, so that took a little bit of thought. I hope I did not blow your mind. I hope you can handle that. Okay, moving on. Okay, for number 11, we are supposed to find the area of the shaded sector. Is this 106-degree angle the correct one to match the sector? Well, yeah, it's right there inside the shaded sector, but you should always pay attention to that and make sure you're doing the right angle. Okay, shaded sector. So, part over whole equals part over whole, as usual when we're dealing with a portion of the circle like this. So we've got 106 degrees over 360 degrees. Okay, now we're talking about area now. So the whole, we're talking about the whole area. So off to the side somewhere, let's calculate the area. So area of the circle is pi r squared. Okay, so that is pi times 9 squared. So that is 81 pi. Okay, that's the area of the whole circle. So when we do part over whole area, the whole area of the circle goes right here. Now up in the top, that's the thing that we are looking for, the partial area. So that's the unknown. 106 divided by 360. Okay, that's 53 over 180. Okay, cross multiply. So that's going to be 180x. See, 53 times 81. Don't forget the pi. Okay, that's 4,293. Don't forget the pi. Okay, and then divide by 180. Okay, let's see if this divides or not. Alright, divided by 180. Okay, so an exact answer would be 477 over 20. Okay, so 477 pi over 20. Okay, we're talking about area, and it was feet, so that's square feet. So that would be an exact answer. If I did the 477 divided by 20, another form of the answer, still exact, would be 23.85 pi. Square feet. Alright, so that's another form of the answer. Or I can just get a total decimal. So I'll go back to this. 477 pi over 20. Oh, I forgot to toggle it. So 74.93. Got to round up. Alright, so that's 3 different ways of writing the same thing. So that's it for number 11. Now number 12. Look, when you have a shape inside of a shape, and you're supposed to find the shaded area between, you're going to subtract. Alright, so you need to look at this as like this. Okay. Imagine that you are starting out with a full square that's all shaded in gray. Okay, and then we are subtracting the circle out of this. So next we got the circle. Okay, I made it a little bit big, but you get the idea. Can I make it slightly smaller? Okay. So if you start with the square and you subtract the circle as though you were cutting it out and throwing it away. So square minus circle will leave you with, you know, the corners here, the shaded area. Okay, so I'm going to make like a visual formula out of this, except for I need to make it much smaller. Let's see, can I do this or not? Alright, so I'm going to make a little visual formula out of this. And the visual formula is this. If we take the bigger shape, the outer shape minus the inner shape, it should give you the part around the edges. Okay, so the whole full square minus the circle should equal, the bits around the edges. So that's the one way to think about it. All right, the outer shape minus the inner shape will give you the border. It's a horrible equal sign. Okay, so anyway, let's find the area of the outer shape, let's find the area of the circle, and then all we have to do is subtract them. So first, the area of the square. Well, that's just 10 times 10. So the area of the square is 100. Okay, no problem. Now, how about the area of the circle? Well, I better do this in white. Actually. Alright, so that was 100. Now, the area of the circle, that's pi r squared. So we need to know, what the radius is. Okay, can you guess what the radius is? Yeah, it's 5. Alright, if this whole way across is 10, the radius is 5. So that means this circle is going to be pi r squared, right? So that's pi times 5 squared. So that's 25 pi. So that's the circle, is 25 pi. So if I subtract these two, that should give me what I'm looking for. Alright, so that's what we do. Okay, so the shaded border should equal the area of the square minus the area of the circle. Okay, I don't know what's up with my equal signs today. And they gave us centimeters, so we're talking about area, so that would be square centimeters. So that is the exact answer right there. Alright, square minus circle, outer minus inner, 100 minus 25 pi. So if I want a decimal, I'll go ahead and put it in the calculator. So 100 minus 25 pi. Okay, so that's 21.46. Alright, and again, shaded area, so that's square centimeters. Alright, so that one was a little tricky if you're not used to it. But again, anytime you want the area between two shapes, just take the outer shape and subtract the inner shape. Alright, this video is getting long. But I'm going to squeeze in two more problems really fast. So we're supposed to find, for number 13, we're looking for the radius of the circle. We're looking for the radius. So look what they gave us. They gave us the partial area. Alright, they said A equals, but this is not the area of the whole circle. See how they have it shaded? So that lets us know that this is just the partial area. So when we do our part over whole equals part over whole, we're going to have 80 over 360. Now this is the partial area, so I'll put that 6.4 in the top. Alright, the total area is pi r squared. Okay, so I could have put like x here or something. But I think it'll work out easiest if I just go ahead and go straight to the total area is pi r squared. Okay, you know what, maybe I won't do it that way. I don't want to confuse you guys. So we're doing part over whole, right? So this represents the area of the whole circle. I don't like that they used A. Normally I use small a when it's a partial area, so let's pretend that they did that. So capital A will be for the area of the whole circle. So let's find the area of the whole circle, and then we'll use that to find the radius. So let's see, 80 over 360. So 80 over 360. So that's 2/9. Okay, so I've got 6.4 over the area of the whole circle is equal to 2/9. If I cross multiply, then I'm going to have 2 times the area, and then 9 times 6.4. That's 57.6. Okay, so if I divide by 2 now, alright, so divided by 2, that's 28.8. Okay, and that's area, so it's square yards. Now, what I just found here was the area of the whole circle. Okay, so we have the area of the whole circle right here. So we should be able to use that in order to find the radius that we wanted. Okay, so let's do that. So now we'll find the radius. So if we have the area, we can use the area formula. So area is equal to pi r squared. So there's the r, there's the radius I'm looking for. But I know what the area is now. So I can take that and put it in right here. So that means 28.8 is equal to pi r squared. So I will divide both sides by pi now. Okay. And that's going to give me some random decimal that I don't want. So these cancel out. I'm going to leave this alone for now. Alright, so because right now I have r squared equals 28.8 over pi. Now if I want to get that r by itself, I would take the square root of both sides, wouldn't I? Alright, so that is going to give me the final answer. That's going to give me the radius. Alright, so the radius is going to equal this mess, 28.8 over pi. So, alright, so I'm doing the square root of 28.8 over pi. So that's 3.03 is the radius. Okay, notice how I did not round until the very end. Yeah, 3.03. And it's radius now, so it won't be squared anymore. It'll just be yards. Okay, so that is the answer to number, whatever that was. Number 13. It's a weird place to put the problem number. Okay, number 14. And this will be the last problem on this video. Okay, again, they gave us the partial area. Alright, this represents a shaded area. And again, I would rather that they gave us a lowercase a for that. We'll save capital A to mean the entire circle. And again, we're supposed to find the radius. Now, the key thing is, are we going to use the 78? No, we are not going to use the 78. Alright, we're supposed to be finding and dealing with the shaded area is what they gave us. So we need the angle that goes with the shaded area. We need the shaded angle. So let's subtract from 360. So 360 minus that 78 is 282. So that is what we have to be careful to use. Alright, 282 degrees, not the 78. Okay, aside from that, it's the usual. Part over whole equals part over whole. Just keep in mind that in the end we want the radius. But for now, we'll do 282 over 360. And now we have area is what they gave us. Partial area goes in the top. So 20.89 divided by the total area. So I'll use a capital A for the total area, so to remind you what you have and what you don't have. 282 over 360. So 282 over 360. That's 47 over 60. Okay, so if I cross multiply, that's going to give me 47 times the total area, 60 times 20.89. Alright, 1,253.4. Alright, so now I need to divide both sides by 47. Alright, remember this capital A is here to remind me that what I've got here is the total area of the whole circle. So I'll just say divided by 47. Okay, well that is a crazy decimal. So I might not be able to avoid it. Alright, I'm going to use the crazy decimal. But because I'm not finished, I'm going to carry 4 decimal places with me. So this is 26.6681. Okay, if you have to round and you're not at the end of the problem yet, use 4 decimal places. Okay, so we found the area of the whole circle, but we're not done because we're supposed to be finding the radius. But now that we have the area, we can use the area formula to find the radius. So I'm going to switch colors on it. So we know the formula for area of a circle is area is equal to pi r squared. So if I take this and plug it in, then that gives me 26.6681 is equal to pi r squared. Now I'm going to divide by pi and take the square root. Okay, if I divide by pi on both sides, okay, and I'm just going to leave it like that. Okay, so right now, because I've already rounded it once, like every time you round it, you're getting more error. So this is 26.6681 over pi is equal to r squared. So if I want to get the radius by itself, I would take the square root of both sides. Okay, so that is going to give me my final answer for the radius. So I'm going to put this in my calculator now. So square root of all that, blah, blah, blah. Okay, so I need the square root of, and I can sort of use this here to help me. So that's 26.6681 over pi. Alright, so that is 2.91. Alright, and the units were square feet. So now that we're down to radius, will just be feet. So that is the answer for number 14. Okay, this video has been extra long, and this is a good place to stop the video. Alright, in the next video we will pick up and start getting into volume. You know, prisms and pyramids and cylinders and spheres. Alright, so I will catch you on the next video.